Hey guys, me Keith, Elder Rock, back on the bench. So today, this is going to be a quick video, but today I wanted to go through this mod, this 5-volt potentiometer mod I made to my power supply. So this is a Defender's power supply, and I have a couple Defender boards in the queue I'm waiting for parts for, but my one Defender board, the voltage is dropping down pretty low to 4.7 volts. And I just wanted to make sure it wasn't a power supply. So when I rebuilt this thing, the power supply, the 5 volts was putting out 4.9 volts. I should have filmed that earlier, but it was 4.9 volts earlier before this mod. Okay, so what this mod is, we're going to come over here to the print. Okay, so this is out of the Williams schematic for this power supply. And so what the mod is, you replace this R2 21.5K resistor with a 10K potentiometer, and that gives you the ability to change your reference between your voltage reference and your input. So that was a little bit low. I don't think that was causing the 4.7 on the Defender, but just for good measure, Williams boards are sensitive to two things: grounding and 5-volt voltage. So I wanted to come in and give the ability to adjust, just to make sure when troubleshooting the board it's not a voltage issue. Okay, so let's look at the schematics. We'll do some we'll locate some things, and I'll show you where the potentiometer goes and all that good stuff. So let's go to the other print. Okay, so this is the component map of the board. I'm going to try to tell you the name of, or the number of the board. We'll do that in a minute. So R1 or R2 in question, this end resistor here, it's your resistor between voltage reference and your input 5 voltage of IC1. So let's come over to the board and show you what that looks like in real life. So yeah, I didn't film taking this resistor out. I did it from the top side because it's all bolted down and everything, but I had nice clean pads from the rebuild, so I went ahead and just worked from the top side. This is the 10K potentiometer variable resistor that I used. Arcade Components calls out one. If there's another video out, the guys over at Arcade Repair and Components, Arcade Components and Repair, yeah, they made a like a short little video. It's pretty good, actually. They have another potentiometer. They sell a pot on their website, but I living in Thailand, it's just too expensive for shipping to order that pot. Like so I got a substitute. So let's go over to the potentiometer I put in. So I put in this Burns 3296 trim potentiometer. So I put this guy in. I picked it up here locally, and it's your standard potentiometer. And this is kind of why I went with it. It has a pretty good insulation resistance, 500 volts DC, and dielectric strength, 350 to 900 volts DC. So that's internal composition, internal material of how they make it. And so this guy, the effective turn on the selector switch, 25 turns, so it's very sensitive, which I like. Standard resistance range, 10 ohms to 2 mega ohms. So we'll see how it works under current. I don't like these technical specs because they're not talking about any kind of current. Any kind of current, like what is the current? Voltage and current. Yes, applications for this potentiometer, exactly what we're using it for. Voltage and current control circuits. That's exactly what we're doing. Analog, the specs. So I guess I should have filmed it because it does have, let me see if I can get it under there. It does have 3 legs. So essentially you bend the center leg over. You can bend the center leg over and solder it to the outside, one of the outside legs. So the wiper the wiper gets soldered to either side of the outside legs. I went with this side just to kind of keep it in the back. You can't see it, but it's a nice. So I just laid it over, soldered it, and then I made my bends. I had the width. To make a nice little bend. Drop that guy right down in there, and it's okay. I like it. So now let's go back to the 5 volts. I already have it adjusted. So if you do this, when you test it, don't have your board connected so you get a reference before you power up anything. So 5.1, it was just sitting at 5. It bounced a little. So okay, let's go through some test points. I'm going to throw the schematic up in the corner of this vid, I think, so we can kind of work along. So I guess with that being said, I'll put the schematic up in the corner and I'll try to hold this still. So because I'm sitting here working. So let's go ahead and measure. Let's measure for our 7.3 on 6 and 5.1 on 5. So we've got 1, 2, 3, 4, 5, 6. 7.07 volts. So we're still 1.5-ish millivolts off there. Let's go to pin 5.01. And my meter died. I tell you what, guys, the battery situation here in Thailand is driving me nuts. I buy the batteries here are just garbage. Okay, so we're gonna go on our, oh gosh, I hate when I do that. Probably just show. Okay, 5.01. It was just at 5.01. Now we're kind of right back where we need to be. So let's check some of our other stuff here. I'm going to put it up in the, so on the IC, I put it like that. Okay, so on the IC, yeah, I don't know. Let's just kind of keep this simple. I think that's about all I want to do. I was going to go through and take you guys through some of this other gain circuitry, but yeah, I can do that. Your clear signal, pin 2. Yeah, that don't make sense. It says 11.8 volts on the print. Oh, I'm looking at the wrong one. Sorry. 5.1. See, that's a little bit low. 5.1 volts there. 1, 2, 3, 4. Should be the same here. Okay. 5. That's right on the money. Yeah, a lot of the voltages are okay now. Let's go pin 13. Should be like 13. Let's see, pin 13, 7.9 volts. That's off pretty good. So, you know, I don't know if it's the parts I used in this or whatever, but let's go through and let's just check now our outputs. So I'm gonna be hitting our 5 volt. 5.01, 5.01, 5.01, that's okay. Not the circuit that we messed with, but let's just check our other voltages here. Pin 1, our -5, that is regulated, I believe. Okay. 2 is empty. Pin 3, 12 volts regulated, just a little shy, but that's holding pretty steady under load. Pin 4. Pin 4 is -12 volts regulated, -13, but that's okay. Yeah, I'm not so much concerned with these guys. Pin 5. 12 volts unregulated, a little high, but that's okay. Pin 6, 12 volts unregulated. Pin 7, ground. These are all grounds. Ground, ground, ground. Okay, then I guess if we go over to our other connector here, so we're gonna go to 4A3, 4J3, -5. That's looking pretty good. Pin 2 is, what is pin 2? Dun, 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 dun. Pin 2 should be, this is AC. This is an AC line. Let's switch that over. Let's switch that over. Pin 2, should be 6.3 volts AC. It's a little off, it's okay. Pin 3. Now we're back to DC. Pin 3 should be 27 volts unregulated. It's a bit high, that's okay. Ground. And then, so I'm just running down the row over here. And then that last pin. AJ3, 6, ground, okay. Not connected and ground, so that's okay. So that's the deal with this mod. We'll get it hooked up to the Defender board now and see how well he does. But I'll get the schematic probably put up in the corner for the duration of this video. So I hope that helps with your Defender power supplies and your Defender troubleshooting. You want to make sure your boards are at proper voltage. The other voltages I'm not too worried about, but this, I think that's going to wrap it up for this video. All right, thanks. Like and subscribe, please.